Combining like terms, adding polynomials together. We've talked about combining like terms back in October. Now we're going to be adding polynomials, which is really a very, very similar topic. It's the same idea. So, quick recap. When we think of like terms, we want to look at the endings. If they have the exact same ending, like x squared and an x squared, they are like terms. You can think of that as, we've talked about x squareds being like big squares. This first 3x squared means that you have 3 big squares. And to that, we're adding 4 big squares. Because they have the same ending, which means they're basically the same shape or the same fruit, however you want to think about it, we can combine that and simply say that there's 7x squareds there. Now, x squareds are not the same as x's. X squared is the area of a square that is x by x. X squared is a big square. X squareds are not the same as x's. Think of x's as a rectangle, something that is 1 by x. We don't know how long this is, it's some variable. So in this case, we have negative 2x's, negative 2 rectangles. I shortened it up. I shortened the length of that rectangle to make it fit better. But all of these have the same length now. So there's negative 2x's. And I'm going to combine that with, right here, I also have some x's. I have 7 of them. So that'd be 7 rectangles. Instead of this being 9x, a negative and a positive cancel each other out or become 0. So this is 0 and that's 0, so I have 5 x's. By the way, sometimes people like to, I myself especially, like to cross off what we've tried to already combine. Helps me realize if I missed something. It also helps me kind of, so I'm excited to know that I'm simplifying, I'm getting the problem done, and then it helps me see what I still have to do. Lastly, we have to combine or add 4 with negative 5. Constants or plain old numbers are also like terms. So we could think of this as like a small little square, or to do it quickly, I make little circles because it's faster for me to make a little circle than it is a little square. So I have 4 positive circles, I have 5 negative circles from right there. So I'll like fill them in just to make them a different color. Positives and negatives. Positive 1 plus a negative 1 is 0. Positive 4 plus negative 4 is 0, but I'm left with a negative 1 right there. Or a lot of you are probably just like, hey, 4 minus 5 or 4 plus a negative 5 is negative 1. You bet. So there's our answer. So I showed adding polynomials there, combining like terms, using shapes. If that helps, please do that. Some of us were using more of a shortcut last October when we were combining like terms. So here I'll review the steps of the shortcut. Look for any subtraction signs. For some of us, if we see minus 2b, we forget that that minus sign makes the 2 negative. So we could look for any subtraction signs and add the opposite. If you don't make that mistake, if you know that this negative or this minus sign here makes this 5 negative, you don't need to add the opposite. But if you realize that you do make that mistake sometimes, it just takes a couple seconds to go through and put that adding an opposite or adding the negative sign with that negative real close to that number. It takes a couple seconds to do that. So here we go. There are some subtraction signs, so I changed that to adding the opposite. Now we try to identify the like terms, things that have the same ending. So starting out in example 2, I see something that has an a at the end of it. So I'll put an underline underneath it. Is there anything else that has an a underneath it? This has an a squared. That's not the same as an a. This has an a. These are like terms. By the way, what's that number in front of the a? It's a 1. 1a is the same as a. Let's keep identifying like terms. Here I see a b. Any other b's? Yep, right there. So I put a triangle underneath both of those, so I'll remember to go back and combine them. There's a constant or a plain old number, so I'll put a dot underneath it. You can choose the shapes that you want to do. Just make sure the shapes of like terms are the same. So like I need to have a dot. If I choose this to be a dot, I have to put a dot underneath this plain old number or constant. What I won't use for this a squared is a dash, a triangle, or a dot. Any other shape, because it's a different term than all the other ones. I'll put a heart underneath it. Start with the highest degree or highest exponent first. That actually goes back to this heart right here. We have an a to the power of 2. There's nothing else to combine, to add with it, or subtract from it. So 3a squared is part of my final answer. Now I'm going to choose to, so I'll cross that off because I've taken care of it. Now I'll choose to move on to the a's. I have 7a. And where's my other a? There's my line. So I'm adding the coefficients of the like terms. These are like terms. I add the coefficients together. 7 plus 1 is 8. But bring that ending with it. It's 8 a's. Cross those off then. Move on to the b's. I have negative 2b plus negative 7b. So combine or add those coefficients. Negative 2 plus negative 5 is negative 7. Bring the ending along. Negative 7b. Last but not least, we've got 5 and negative 7, which is negative 2. So let's write down minus 2. If you wrote down plus a negative 2, that's also equivalent. Like a multiple choice test or an ACT, they will write it this way. It is the same as having adding a negative. You'll need to realize if you do that, that's the same as this and choose this answer. Oh geez, sometimes we're subtracting polynomials. And when we're subtracting the whole polynomial, it's gonna make the first step a little bit more important. So we're gonna have to make sure we add the opposite or distribute a negative 1 to everything in that subtracted polynomial. This makes each term in that subtracted polynomial opposite. Let me show you what that means. So here, we're taking this polynomial minus this polynomial. We're taking all of this off. Remember, subtracting is the same as adding the opposite. So I'm going to actually make 4 marks here. 1 mark to change this to adding, and 3 marks to make each of these terms the opposites. I'll take the opposite of that, the opposite of this term, which is positive right now, and the opposite of this negative term right there. So when I go through and actually change this to adding, I'll now make these opposites. So this negative 2 becomes a positive 2. This positive 3x becomes a negative 3x. This negative 4 becomes a positive 4. Everything in the subtracted polynomial got switched to the opposite term. Are there any other subtraction signs? Again, if you're going to forget that this x is actually negative, add the opposite. Identify like terms. So now we're exactly back to what we were doing on example 2. I have an x to the third. Ooh, I better use a thinner pen here. X to the third, I'll put a heart underneath it. Any other x to the thirds? Yeah, right there. I'll put a triangle underneath x squareds. I'm just making the shapes up. Any other x squareds? Wah, wah. No, there's not. I'll put a circle, a big open dot underneath x's. Any other x's here? Right there. I'll put dots underneath constants. Dot, dot. So now I can quickly visually see the like terms. I'm combining negative 2x to the third with positive 2x to the third. So we're going to add the coefficients of the like terms together. So negative 2 plus positive 2 is 0x to the third, which we don't actually need to write down. So these are eliminated. They make 0. Next we have x squared. It's 5x squared. There's no other x squared, so we don't add or subtract anything to it, but it is part of our answer. Move on to the x's. We've got negative x plus negative 3x. Now, if you want a number there, that's a negative 1x. So negative 1x and negative 3x is negative 4x. And then we have 8 plus 4, which is 12. Good. Let's try that one more time. Boy, we're subtracting off this whole polynomial right here. Everything in the parentheses will become opposite once I change this to adding. This subtraction sign only affects or oppositizes what's in the parentheses. It does not affect the symbols over here. So this will become adding a negative 2x squared and adding a negative 3 and adding a positive 4. We've just made every term in that subtracted polynomial opposite. Now, you could notice these minus signs here, like we've done in the past. Change them to adding the opposite if that helps you. Now we identify like terms. So here's an x to the third. No other x to the thirds. Here's an x squared. There's an x squared. Here's an x. There's an x. There's an x. Here's a constant and a constant and a constant over plain old number. All right, so now let's go through and start combining like terms. Find the highest degree first. There we are. So we have negative x to the third. Nothing else to add or subtract from it, so that's part of our final answer. Let's go to the x squared. We have negative 2x squared and negative 2x squared. That's negative 4x squared. All right. Let's go to the x's. We have 3x and negative 3x and negative 4x. So that's negative 4x. Last but not least, numbers. 8 plus 4 minus 8. That's going to be a positive 4. There we are. So again, we talked about adding or combining like terms. However, if we have a subtraction sign in front of an entire polynomial, we need to add the opposite of that. And then after that, we're adding polynomials. So it's just like examples 1 and 2 from there. There should be some examples of the assignment that you have to go along with this nearby the link that you found this at.